When we open the program, the first thing that's going to come up is tips. So we can number of tips that we can go through. There's over 50 tips you can go through. The next thing we're going to do is we're going to pick the fully aerobic model. Fully aerobic model gives you just an aeration tank and a clarifier. The next thing we're going to do is pick the units we want. We want gallons, we want hours, we want pounds, days, we want feet, we want Fahrenheit, and we'll use BOD. And then the next thing that we're going to do after we get picked the units that we're going to use, we can pick metric if we want to pick metric, and we'll click our inputs. For this particular program, we're going to use just the inputs as the default in the program are. So we don't, but we can change any value that we want in any of these boxes for the particular influent that you're working with. The next thing is we're going to pick the secondary clarifier. Secondary clarifiers are plan options, and we're going to put in the actual volume of our secondary clarifier. And once we get that inputted, then we'll come next to, we'll make sure that the sidewall depth and everything else is coordinated. Then we're going to go to output. So we're going to see what the biomass is. We're going to go to our aeration output. And we know that our blowers are running about 10 kW. We're going to be using one blower, and we'll probably run it 10 hours a day. So we put a 0 in there that we're only running one blower. The next thing we'll come to is what other outputs we're going to go for, and we want to look at start. Okay, and then at start, we're going to put in our town, and this is being designed by the engineer. Once we do that, then we can go up here and we'll do a quick design. We can do a quick calc, we can do troubleshoot, we can do a quick start. Let's just pick quick design. In the quick design box, we're going to put in the volume of that we're going to treat on a daily basis, and we're treating 72,000 gallons per day. So, because we were working on a day from the previous screen. And if we don't know those settings, we're going to pick conservative settings. We're going to pick our, it's going to compute our estimated volumes, and we can actually put our own volume in there of our particular process, and we'll get to that a little bit later. We'll put in our clarifier, and the next thing we're going to do is we're going to finish. At the finish tab, we're going to see what the actual plant is, and we're going to go to diagnostic tests. Now, because we've got a high solids retention time, we're returning quite a bit, we have to increase our effluent alkalinity a little bit because it's below 50 and we got to get it above 50. So we'll have to add some sodium bicarbonate to the plant. The next thing is the aeration system. We're checking on that, and that is underpowered. So we're going to increase that to 11 hours a day. At 11 hours a day, we'll go back to analyze. We're still underpowered. Let's go back to setup. We change it to 12 hours a day. Analyze it, and kick diagnostic tests, and so our aeration system is okay now. Next thing we're going to do, we close this off, and we can go up to reports. We can click on what we want to do, the ratios, the reactor, diagnostic tests. We can preview the reports, look at them all, and we can print them. And we'll go back to aeration, and now what we want to do is we want to go back to setup, and we're going to go and pick the different type plant select. We're going to use the Werman process, and the Werman process is one of the many biological nutrient removal plants that are available in SASPRO. We're going to go to our inputs, which are the same as for the fully aerobic plant. We're just going to use those same inputs. And then we're going to go to the back to start for the outputs tab, and we're going to look at our units. Plant select, start. We're going to do a quick design again, and it's going to be the same. The 72,000 conservative figure, operational suspended, total suspended solids operation is just put it at 3153. Gives a little more volume, but let's go back and change it to what it was originally. It's the 3815. Next, and then we use that value, and it tells us the size of the anaerobic, the secondary anoxic, and the reaeration tank. Once we're done with that, we can hit finish. We make sure we have our secondary clarifier in there. We put in the 226.1 square feet of clarifier, and then the total effluent in our nitrogen, our diagnostic test, our total nitrogen was still high. So we're going to go back up to setup, and we're going to outputs, and we're going to hit effluent, and we're going to click on total nitrogen in the effluent, because we want to know what the total nitrogen is. Now our total nitrogen is 24. However, that's way too high, so we're going to go back up to plant options, click on carbon dosing. We're going to set up carbon dosing. We have methanol, molasses, other carbon. So we're going to put it micro C. I don't know if many of you heard of micro C or not, but micro C is a non-hazardous, non-flammable, and one heck of a lot easier to use than methanol. So we're going to say OK to that. We'll go back out to analyze, and there is our carbon dosage, just Q sub dP. And we'll try 10 gallons a day and see what that gives us. We'll get down and hit on 10 gallons a day, put it down to 3.4, but we're overdosing. So let's go down to 9 gallons a day, and just overdosing slightly. But now our sludge blanket is 6.3 feet. It's above the feed point. We don't want that. So now we're going to back off a little bit on our solids retention time, and we pass the diagnostic tests. Now that the diagnostic test is all done, we can go up and do our reports and look at our reports. We can click carbon dosing on this one also, and it gives us our reports. Now we're done with the very first phase of it, and then the next phase of it is going to be we're going to take a look at going into our existing aerobic system versus what came out on the SAS Pro. So we're going to go in here. We have two aeration tanks. Their length is 36. They're 12 foot wide. They're 14 foot deep. That gives us the volumes, the clarifier volumes. Then we're going to go over to the other side of the equation here, and we're going to insert the values from the Wurman simulation that we just did. And once we insert those, we have 61,000. Here it's 19, and here it's 5192. That gives us the total volume of the Wurman process. It's 104% more than what we actually had before. We had 90,000 before. So then this little at the bottom tells us where we need to put the divider walls in the aeration tank.